This Japanese trick is a compound that costs $2, not a dealership charging port service. $2. One 5-minute application cuts the energy lost as heat every time you charge your electric vehicle. Japanese fleet technicians have used this for years. It is why a Nissan Leaf taxi in Tokyo runs the same charging port for a decade without a single replacement. In the 10th place, a simple tube of silicone-based dielectric grease introduces our central mystery. Often sold for just $3 to $5, this basic compound represents a quiet, preventive habit rather than a flashy aftermarket upgrade. It is a protective barrier designed to keep moisture out and prevent physical wear on the rubber seal. The core question is straightforward: can this cheap material truly preserve charging performance over years of daily use? The reality rests on history, basic physics, and correct application, turning an overlooked maintenance choice into a practical shield against steady wear. Number 9. This protective compound is no modern electric vehicle invention. Long before the first lithium-ion car battery, technicians trusted silicone-based dielectric grease to survive the absolute worst environments on Earth. Its lineage tracks straight back to heavy marine wiring, aerospace avionics, and military connectors engineered to withstand relentless vibration, extreme heat, and moisture. The United States Navy relied on these specialized formulas to protect critical shipboard seals and slow down the physical wear caused by repeated plug-in cycles. From there, the compound migrated into everyday civilian work, keeping spark plug boots, battery terminals, and outdoor electrical panels from failing. It is a proven, decades-old shield. 8th place. This brings the practice into the high-stakes world of commercial operations. In Tokyo, urban taxi fleets and delivery depots face relentless daily fast-charging cycles. For these fleet managers, a worn charging port is not a minor inconvenience. It is an expensive vehicle off the road. To protect uptime, preventive connector care became standard depot routine rather than a hobbyist option. Fleet technicians are trained to apply a thin layer of silicone dielectric grease directly to the charge port cap seals during scheduled inspections. This simple habit preserves the weather seal, stretching the life of expensive charging assemblies to nearly a decade instead of the typical 2 to 3 years. It is pure economics, turning a cheap maintenance step into massive fleet savings. Number 7. Every plug-in cycle exposes the metal contacts to air, moisture, and intense heat. Over time, this constant heat cycling triggers a quiet chemical reaction: oxidation. A microscopic insulating layer slowly develops over the metal. Even if the plug looks completely normal to the eye, this hidden film causes electrical resistance to climb. In physics, resistance acts like a bottleneck, forcing current to fight its way through the terminal. Much like a corroded wire in a home electrical panel, this friction generates heat. Valuable energy that should charge the vehicle is lost directly at the plug. This is basic electrical degradation, and stopping it requires early prevention before permanent pitting destroys the port. Number 6. The math behind charging losses relies on a fundamental law of physics. Power loss equals current squared times resistance. In this equation, current is the accelerator. When 30 to 50 amps flow continuously through a level 2 home charger for hours, even a microscopic resistance increase of just 0.05 ohms forces the plug to fight. At 50 amps, that tiny hurdle dissipates 125 watts of continuous heat directly at the connector interface. This energy leaves your wall socket but never reaches your car's battery pack. Instead, it bleeds off as pure heat, baking the plastic and rubber seals. Over hundreds of charging cycles, this minor efficiency bottleneck quietly compounds into real, avoidable waste. Number 5. Why does the EV industry not put this cheap routine on the front page? The reason is incentive-based, not conspiratorial. Traditional service ecosystems generate reliable revenue from paid diagnostic visits, scheduled inspections, and complete charging port replacements. A $5 tube of silicone grease threatens this recurring revenue cycle by significantly reducing wear. Standard owner manuals remain deliberately generic, advising drivers only to keep the inlet dry and free of corrosion. High-usage commercial fleets operate on a different economic scale entirely. Because fleet vehicle downtime is their single greatest operational expense, fleet managers prioritize prevention over repair, quietly adopting this maintenance habit to bypass expensive dealer service loops. Number 4. Safe execution begins with absolute power isolation. Before attempting any maintenance, the vehicle must be completely powered down and unplugged from the outlet. The first step is a close visual inspection of the port, checking for debris or wear before any tool touches the contacts. If the metal surfaces are dusty, a gentle wipe with a clean, dry cotton swab or microfiber cloth is all it takes. Only use a tiny drop of high-purity isopropyl alcohol if you spot minor surface discoloration. Avoid water, WD-40, or petroleum-based spray cleaners. These common household solvents degrade delicate rubber seals and leave sticky residues that attract dirt, completely ruining the physical connection. Number 3, the absolute core of this entire routine is the seal-only rule. This protective silicone must be applied exclusively to the rubber gasket and weather seals around the port opening, along with the matching gaskets on the cable side connector. It must never, under any circumstances, be packed directly onto the metal electrical pins. The fundamental goal is simple: block moisture and protect the delicate sealing surfaces before real contact trouble begins. Instead of stuffing the port, apply a microscopic, paper-thin film. It takes less than 5 minutes. Perform this simple maintenance routine twice a year, always at room temperature. This strict, careful application keeps the high-voltage path dry while sealing the elements out. In second place, this protective routine has a hard boundary line. It is strictly a preventative habit, not a cure for existing damage. Applying silicone grease blocks moisture and slows wear before it starts, but it cannot restore pitted, charred, or heavily corroded metal contacts to factory condition. If your charging inlet already shows visible pitting or structural wear, the maintenance window has closed. At that point, applying grease is useless, and your immediate next step must be a professional technical inspection. The financial contrast is where this routine proves its worth. Spending $5 on a tube of silicone grease and devoting 5 minutes a year prevents complete connector failure. Once a port melts or burns out, replacement costs quickly scale from $800 to over $3,000. By treating this as a strict habit of early preservation, you adopt the precise cost-saving logic of commercial fleets, keeping your EV running efficiently for pennies. And finally, in first place, the before and after results of long-term connector wear reveal the true value of this practice. When technicians monitor charging ports over years of continuous use, the physical data shows a clear divergence. Untreated charging ports experience a steady upward climb in contact resistance as moisture and air slowly oxidize the metal contacts. This causes temperature spikes that bake the weather seals, leading to eventual failure. Applying a microscopic barrier of silicone grease directly to the rubber gasket completely halts this decay cycle. The physical connection remains clean, dry, and stable, preventing the microscopic bottlenecks that turn electrical energy into destructive heat. This outcome solidifies the core principle of the Japanese method. It is not an engineering miracle or a quick fix for a melted charging inlet. It is simple, preventative physics. A $5 tube of silicone grease and 5 minutes of annual care act as a shield, stopping microscopic degradation before it starts. Once metal contacts are pitted or charred, the maintenance window closes and only an expensive replacement can resolve the issue. By acting early, commercial operators and smart owners protect their charging infrastructure for pennies. This small, deliberate maintenance habit keeps vehicles charging at peak efficiency, avoiding the $1,000 service bills that catch unprepared drivers off guard. It proves that a tiny bit of discipline beats a massive repair bill every single time. Across every step, one truth remains: high-tech vehicle reliability still relies on low-tech prevention. It is not folklore, it is simple physics. Small, deliberate care stops connector corrosion before it starts, protecting your wallet from costly replacements. Have you tried this yet? Let me know below.